My name is Eric Vink. Been working in V6 for many years as well as the IETF. So when we talk about potential talk for this week, and also suggested, hey, what's happening in the IETF? I mean, not in 97, 98, but in the recent year. So just to introduce you about the IETF structures in multiple working groups dedicated on one topic. There are about 30 working groups. They are grouped by areas, but many working groups are basically working with things related to V6. And I'm using here some slides coming from the introduction to the internet area done by Suresh and Pascal here. Of course, one big interesting working group is 6-man. It's called IPv6 Maintenance, the maintenance of all the existing RFC. Okay. And basically everything that you need to change one bit in one IPv6 packets needs to go there. You want to change an array, needs to go there. You want to change the protocol timers, it goes there. So they are basically the gatekeeper for all the changes. And including address privacy, and this is basically what Fernando will talk into the second part of this talk here. There are other working groups such as 6LoW, which stands for 6LoW, everything which is low bandwidth, pretty much like near field, for instance, power line, and everything. So it's the adaptation layer between IPv6 and another layer 2. Because guess what? Not everything is running on .1.3 or .1.11. Many changes as well there into the neighbor discovery, because not all of those network layers, the layer 2 network, support multicast or broadcast, or a few of them don't have full connectivity between all the nodes. So they need to change a neighbor discovery here. Another one is 6TiSH. So very strange name, so don't be afraid, right? Don't panic by the name. It's simply time slot channel hopping. So it's a way to transfer data on a very low rate, but very well organized. So there's a kind of matrix, and pretty much like in the years of token ring and token bus, you can talk now. You can talk now, so you know when you will need to talk. So it's good for some kind of latency in some application, but of course IPv6 is not being designed that way. So we need, again, another adaptation layer, but this one is pretty big. What's nice there, and what we see more and more at the IETF, is open source, which is coming there. For instance, the IETF starts this Saturday in Prague by 2 days of hackathon. And a lot of now protocols are designed and implemented at the same time. This is brand new, the IETF compared to a long time ago. Another working group is IPWave. And quite often the acronyms is interesting. So it's IP wireless access for vehicular environments. So it's from car to car or car to infrastructure. And again, if you think about moving cars, they don't have a lot of time to synchronize and do a few things, right? Because if you're driving 130 kilometers an hour or higher here in Germany, and you are crossing to each other, very little time, right? And the same thing if you are hopping from one access point to another access point or something like that. So again, sorry, they got a very specific mode of use for Wi-Fi, and the transmission of V6 packets there is also slightly different. V6 ops, IPv6 operation. That's one which is really interesting. And the job that you did, Chris and Enno, with your student should be presented there at some point of time. It could be documented even into an internet draft. Doesn't need to be, I shall come back on this in the magic there. That's what I say. That's real world experience I'm meeting academics, right? Compared to 6-man, where this is basically kind of the gatekeeper, making a change there is very difficult on purpose. While here, it's more about dynamic and testing stuff. So really important. And of course, they do some implementation-specific recommendation. HomeNet, it's basically based, mostly closed, but this is the home network as we know. And doesn't have a lot of success in implementation into HomeNet device and Netgear and the Linksys. But it's a pity, because what is happening right now when you put, let's say, Netgear or Linksys or whatever that you buy at the MediaMarkt or another place, it basically is doing NAT. So if you have a router, you place a router beyond your ISP router, your V6 may be into the ISP router, but the device that you install is only doing IPv4 NAT, doesn't do anything about V6. And if you put an access point behind it, it will do NAT again for IPv4. So in IPv4, it works because you can do NAT, a second layer of NAT, a third layer of NAT. Not great, but it works. In IPv6, you need basically to distribute all the prefixes and do some routing. Okay, so if you put multiple, let's say, consumer-grade boxes in IPv4, it works thanks to NAT, 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 NAT. In IPv6, you need to do some routing there. And this HomeNet is basically about this. Or we can get multiple access, so multi-home network, and you can translate all those prefixes. Mostly done, by the way. Software, this is where the DS Lite were coming through, the MAP protocol, both MAP encapsulation and MAP translation are working and coming out of software. So software is mostly closed now. I think we got all the mapping, V4 over V6, V6 over V4. I mean, years ago it was 6RD, but now we are there. And so this working group will close anytime soon. A brand new one is this one, Distributed Mobility Management. It's everything which is about mobile. Typically into the 3GPP environment, so the handset, or even with 5G, is how can we, for instance, find the content? Can we store some data close to the base station rather than in the core, as well as changing from one network to another network? Okay. And all the mobile IPv6 extension are there. Pretty much like the 6-man is for the IPv6 maintenance. DMM is also the extension for mobile IPv6. Mobile IPv6, by the way, being one of my big deceptions in IPv6 because nobody is using it, right? But it could have been so nice. Something which is also starting is this LWIG, Lightweight Implementation Guidance. It's about IoT device or very lightweight implementation, not linked only to IPv6, but how can you do a lightweight IPsec? How can you do a lightweight NAT64? How can you do a lightweight neighbor discovery? Right? So not using a lot of memory, not using a lot of CPU power, for instance, and power. So very interesting working group. And it's basically sharing experience, right? So we don't specify how to code, but it's basically, hey, I've done it this way, this is better. And a brand new working group is about GitHub. So we'll meet for the first time in Prague next week. It was above before. And it's not about standardizing the specification of the GitHub protocol. It's more how we can use as authors at the IETF GitHub, because that's just a document, right? So we can use it for control, issue tracking, and so on. My biggest concern there is that the charter, so the working group must work about GitHub, but it's IPv4 only, right? So it looks like you are hinting that some change are coming, but I find it shooting ourselves in the feet, right? If the IETF is working on a group that does not support IPv6. Anyway, this was basically a quick browse through working groups linked to IPv6. Now let's go and look about some recent RFC. Most probably you have seen this one, due, right, for a long time. The previous RFC 2460, which described IPv6, was not on the standard track. So this RFC 8200 is now on the standard track. It's even a standard, right, 86. So there are different levels in the IETF and the RFC. It's mainly about clarification. In the addressing, for instance, it also says that fragmentation within the extension network chain should not be permitted, and you should discard them. So quite cool. That was the biggest security issue. So nice. Another one is this one, benchmarking methodology for IPv6 transition techniques. So, and by the way, there is also BMW. I think it's interesting in Germany. So BMW benchmarking working group. doing a few of those things. It's basically, if you do performance evaluation, like DNS 6.4 and NAT 6.4, there is a DNS portion there impacting the performance. So it's not only about the NAT 6.4 itself, but you also need to take into account the establishment like DNS 6.4. That's basically it, right? So that's the reason why they wanted to get something very specific for those techniques. Talking about performance measurement, another RFC, and it's a very interesting one, and I will grab some water. It's about the performance measurement and the use of destination option header. So we start to see, and I'm quite happy about this, we start to see use of those extension header for good reason. So there was the source routing, for segment routing, but destination option is there. So it's basically there. Remember, destination option is basically when you are reaching a destination and only the destination should look at it. And by the way, you can have two destination option header into an IPv6 packets, one at the real destination and the other one and the first hop just before the routing header. Again, it was designed for this for mobile IPv6, right? When you go for the first hop, the care of address before going to the home address, there was two decision options. That's the reason why. We can use it here. And one specific decision option header, and it's standardized here, can say, for instance, there are sequence numbers and timers there. So it could be useful. Now, I don't know so many implementation of it, though, but can be used. And what's nice here, you can see it's sent from very different V6 addresses. So it goes through the internet, which was quite interesting because, I mean, at first it's designed to go through the internet, so there can be a third parties on the path doing nothing. And hopefully, of course, we can cross finger that the extension header will not be dropped on the path, which is not granted, as we all know. So there is another one, IOAM, the in situ OAM, which, hey, Eric, that's the same thing, right? So why are we using two different things to measure performance? But this one is different. The one on the slide, the RFC, is end-to-end. The routers on the path are not managed, they don't care. In this case, in situ OAM, this is within one administrative domain, so one operator, one enterprise, is using hop-by-hop extension headers mainly, and it requires supports on each and every router. And each and every router on the path is putting timestamps, and also can signs that this packet is going through this router. That's very important for security. If you want to do network function virtualization, and you want to ensure that you go first by the load balancer, let's say, then by the VPN termination, and then to the server, for instance. You want to enforce a specific path in all those NFV. Okay? So with this, you can see the proof that, yeah, it's gone there, there, and there, based on crypto. So quite cool. Another one from my friend Günther and GGB. We have so many V6 addresses, right? So currently, you are pretty mean, Chris and Enno, because you give us only one shared IPv6 prefix for all of us. So Johannes, Enno, and Veronica, we are sharing the same V6 prefix. This thing says, hey, what if I am replying to the router solicitation and I give one router advertisement to Fernando with one prefix, to you, Veronica, another unicast with another prefix? So all of us has got different prefixes, which is quite cool because how can you do a rogue area attack? How can you do man in the middle? I mean, you can still do it, but naively you will think that my prefix is the one used by everyone, but I don't see any other traffic. Quite cool. Is a side note. There are talks as well, and people are doing it by using DHCP prefix delegation, for instance, to give a /64 for each and every host. Okay? The previous thing is just a hint to do it, right? I'm sending you a route advertisement unicast, but the host doesn't know it gets a /64. Here, the host knows that it got a /64. Why could it be useful? Simply because if you have a lot of containers in the V6 part, which is the interface identifier, you can put the time when the container started, and you can put as well the container image ID or anything you want into the address. Because you have so many of them that if you even if you create a huge amount of containers initiated on the fly, 1,000 per second, you can still get a unique IPv6 address. And then in the log, oh, you were talking to this V6 address. Oh, but it was at that point of time, it was started with using this image, right, for the container. So it could be very useful for fingerprinting, so for auditing, basically. Another one. Everyone knows about API Ball. Apple and Tommy made a version 2 of it. It's simply clarification. It also specifies a 15 milliseconds preference. So even if you get the A before the quad A, you wait 15 milliseconds to get basically the quad A and start V6. It also specifies what to do when you have multiple DNS servers, like I got a few of them by DHCP, a few of them by the array, or by other interfaces as well. So how to handle this. So this one is interesting. So two guys, one from Intel and one from Marvel, say, hey, there are API packets before in V6 that are terminated on the internet by some middle boxes like firewalls or whatever, and this is bad. So they specify it. Now, right? And that's really an April Fool's Day RFC. So we are doing this. Again, that's 2 or 3 every year. So really look about this 1st of April. That's coming in 2 weeks. Time frame next Monday in 2 weeks. You should go in. And on this one, they say, hey, for instance, packet can be terminated, and it was obviously a joke, by color, so racist. Color of the packet is this quote point, right? The age is, this is, of course, the hop limit. And the origin, oh, you are coming from, I don't know, this country or this country, based on the source address. A very nice one. You should read it. Again, just a joke. DHCP v6, and many, many people involved there. As a new revision, like a new document. But it's the same protocol, right? So they changed nothing. It's still the unique DUID, which is used. And we still do the lease through the DHCP unique ID and not to the hardware client address. It was mainly about clarification, basically. This one from Jen Linkova at Google. Yeah.
May I ask a question about
sure.
DHCP?
Sure.
You can skip the question if you want.
I will most likely skip it, but yeah.
Okay. So I have a question. Why, when you look at the IETF, so there's DHCP version 6. Still, everything that is useful in DHCP is kind of like ignored and being replicated in arrays. So my question from the outside, if you want, is if we're going to go that way, why not just get rid of DHCP altogether?
Yeah. I have no clue, right? So it's not to the IETF to say, hey, use this or use that. It's
you would have to persuade all the vendors to support one thing.
That's
Yeah.
You get people to agree, right? ISN operator has to support both because my IoT vendors or network infrastructure vendors, they suspect that for example, access points will have access to IPv6, so they can actually allocate by option, while somebody else expects DNS, so make the world agree, and then there will be one.
But even this, right? So it's there. There are some implementation. I think it will stay for a long time. Now, you need it as well for DHCP PD, for instance. But the IA, we could scratch it. I do agree. And you will see later on has got also an experiment to extend and put whatever option you want into a route advertisement.
So my thing is, I don't care whether we go the RA way or the DHCP way, but for me it's kind of like a mess when you have the two things in two protocols and different people support different stuff.
I do agree, it's a mess, and specifically when the array is configured by somebody which is networking department, while the DHCP is typically done into the server department, and they don't agree with what the content would be inside. I don't know if you have seen this, it's pretty messy in this case. Anyway, so it's there for living, and again, the IETF doesn't recommend stuff or whatever. We provide you with protocols. So Genlink cover was, again, using route advertisement for enterprise multi-homing. Wow. So it's basically when an enterprise, or actually a consumer, has two uplinks through ISP A and ISP B. So you receive two prefixes, so you're advertising inside your network prefixes from A and prefixes from B. And then you need to select the right outgoing router. If you're using prefix A, you need to go egress through ISP A. If you egress to ISP B, anti-spoofing will drop your packets, right? And you need to be resilient. So that's basically it, right? So this is, again, coming from a slide from Jen, and she likes cats and assume that the internet is only to look at pictures of cats, right? Maybe that's right. So two routers, two ISP, and you need to be sure that you exit by the right one. A very, very simple way of doing it is relying both on the source address selection and on the route advertisement itself. So if a primary link is operational, so you have two routers, address from the other, the backup prefix, should not be used. Okay, so you can say, hey, I got a prefix from B, but the preferred lifetime is 0, so I don't using them. But I am the preferred router, I am sending you prefix A with a preferred lifetime, which is higher than 0, so you will use it. And now, if ever the uplink goes down or the router goes down on router A, we need to change. Okay? Basically, we need to send a prefix B is now preferred lifetime greater than 0, and the router itself has got a preference higher than 0. So you will use both the router and the prefix. So that's basically how she's doing. Rather right now, if you say whatever language, router, prefix blah blah, preferred lifetime a big one, you change it into something if some condition are true, could be the router is up or the interface is up, or we can ping on the next stop. Then I send the preferred lifetime to something which is higher than 0, else lifetime 0. And then it works for the host. Now you need to find a way of doing this on routers. Okay. I don't know about no routers doing it, but most of the routers nowadays have got some scripting language. Then you can use to do this. And it solves a nice problem. Now, if you think about it, it solves only the problem for the next LAN. Because if I go back, it will solve the problem of those hosts. But if you have multiple routers in the hierarchy, you need to apply the same thing in all the routers. Okay? If you have, let's say, typically an access router, and then a distribution, and then another access router, you will need to play a couple of tricks there. But it works. She tried. Yeah.
Did they consider that they might be switching to something that doesn't work? So that's a problem when you have things that are not getting used.
That's exactly, and you're perfectly right. Some condition here must include things like you. If I'm advertising this prefix, I need to be sure that the router and all the egress points and the next stop are working. Else you're in trouble.
If you're only using one and then fail to one that doesn't work.
Yeah, but if you fail to the other one, it's also failing. Then if you have two failure, you have two failure, right? So if you have only two egress points, one is failing and the backup is failing, of course there's no answer there, right? So okay, then Lee has got something, an RFC about reverse DNS for internet service provider. You remember? Reverse DNS is my personal nightmare. I can do it in IPv4, right? It's by hand. But in V6, specifically when you have many, many zeros, I mean, I can count 1, 2, 3, 4, and then after we need to use a pen to count the zeros because I cannot do it. I mean, my brain gave up. So in the sense of for a service provider with residential users, he proposed, for instance, to reply no such domain. So you reply, right? So don't let the resolver pending in the air waiting for timeout. So reply immediately with basically a negative reply, no such domain. Or wildcard match, residential user .deutschetelecom.de. Why not? DNS, dynamic DNS update. You can do it. Now you can do it either by the residential gateway, so the home router, that will do it on the behalf of all the hosts, or you can ask the host for doing this as well. Or you can delegate the DNS zone to the residential gateway. A couple of proposals here, but no real solution. There is an RFC that has come as well, which replaces another one, which is IPv6 node requirements. What is it about? That's basically a roadmap telling, hey, please read this and this and this, Mr. Implementer or deployer. But you don't need to use everything. But just beware, for instance, of fragmentation. Beware about source address selection. And they say, to come back to Fernando's point, SLAAC, stateless address auto configuration, is mandatory. DHCP is optional. Yeah.
This optional DHCP, isn't it should in capitals?
It's a should in capital.
So should in capitals is not
Or may, I don't know. I don't remember.
I'm pretty sure it should in capitals. And then just for clarification, should in capitals is pretty much mandatory, right?
It says you can.
I'm not from the idea.
No. The should is say you must do it except if you have good reason not to do it.
Exactly, which is not what I would consider optional.
I don't remember.
Yeah.
Sorry. So, for instance, also they say that DNS over route advertisement is mandatory. So it's fixed there. A few things regarding new features that come since the last time. And even they remove a few things from the latest RFC. I mean, IPv6 over ATM. I mean, it goes back, right? IPv6 was at the same time when ATM to the desktop was there. I mean, I'm old enough to have seen this on slides at least. Anyway, going now through the internet draft. So internet draft are just draft, okay? That's not because they will be here, that they will become RFC, that they are supported by the IETF, they've been reviewed by other people, or there is even an implementation. It's just to give you some ideas that where other engineers are working. You know, each and every internet draft has got an expiration time a few months before. So about all the internet draft at the IETF, there are about 300 of them having IPv6 inside. So important, isn't it? This one, and basically it's coming from Bob Hinden. Bob is one of the two guys implementing and specifying IPv6 years ago. It says is IPv6 route advertisement with an IPv6 only flag. Because when you look about here at Troopers, at least on my Mac, I still have an IPv4 address, even do the IPv6 only SSID. The 168.254, right? The link local. And also my Mac spends some time doing DHCP v4, and I'm pretty sure it's sending DHCP v4 packets with discovery every minute or so. So the goal here is to send into the route advertisement one specific flag that tells there is no IPv4, no need to do DHCP v4, no need to get a link local, right? Because in some case, you can, even this link local, and again, 169.254, could be blocked because some network will only allow IPv6 packets, right? 86DD as ether type will block completely all the IPv4 one. So even if you have a link local v4, you maybe have no communication with other link local IPv4. So you need to know as a host. So obviously, they cannot be done over DHCP v4, right? Because there was some assumption, yeah, what about adding an option in DHCP v4 telling, hey, there is no v6 here? I mean, come on, right? Let's be serious. So we cannot do this, right? Now, the only thing is that there are only about 10 or 16 bits for putting flags into route advertisement, and a lot of them are already used. So it's just more like a smile. Exhaustion of those flags into the route advertisement is closing. Another one, and if you were there last year, I think I presented this slide. That's another point of view about the multi-homing. And typically, when you have one laptop can be tethered to a mobile phone, you can go over Wi-Fi, you can go over Ethernet, the classical ways of multi-interface device, and you can get two ISP, for instance, and you can get a VPN provider going back home, so you can basically have multiple addresses and multiple exit points. As I said, how you do it with IPv4, and you've been warned, not. It solved the problem, right? Because if you are using, anyway, you have only one IPv4 address on one interface, you can this way, and if you select this address, you go, let's say, over Wi-Fi, and you will go there, and this one is going NAT, and the return traffic will go through there. Else, if you have multiple prefixes in V6, you can, for instance, use the address from here, exit there, hoping that you are not anti-spoofed by this one, and traffic may come back by this way, and all your firewall and stateful device are lost because there are no state. So we need to find a way. And one way is what we call destination and source routing, or source address dependent routing. What is this? So we'll be routing not only based on the destination, like you do normally, but you will also do routing based on the source. So whether you use the prefix A or B or C, you will follow a different path in your network. So we basically extend all the FIBs, so the forwarding information base, so that's basically the rerouting table if you want, with a source prefix. We will say this route or this FIB entry is only valid by this source address. And there is any keyword which basically sends A from any source address. I think I got an example here where, for instance, very simple FIB entry. For any source going everywhere, you use router 3. From this specific prefix going everywhere, again, router 3. Now, a more specific prefix going everywhere, use this exit point. So this could be, for instance, that's the prefix I got from my VPN. So when I'm using my VPN, I need to go to this router, for instance, or whatever. So it basically allows you to steer traffic on one specific path. And the beauty of it, and I use router 3 and router 4 just to solve the multi-homing system here. You remember router 3, router 4 on the previous slide? You do not need to touch the routing in all other routers, because those routers will route you basically based on the destination. But on those two, if you have source and address destination routing, they will, you don't need to go by me, you need to go there. Okay, so the packets will go, for instance, this way, and router 3 will reroute based on the source to the other exit router. Oh, you are using the prefix from ISP2? I know. From the source address, you need to exit this way. Another way of solving the multi-homing issue and addressing as well the anti-spoofing. That's basically what I said here. But now, you also need to know which, in the case you have multiple prefixes advertised to you, which one should I use? So there is the source address selection that selects the closest to the destination, right? The most common bit. Not always working fine, because in some case, you have part of your prefixes that are reachable only via the internet or only via the VPN or only the intranet, for instance. So there is the concept at the IETF that exists for a long time of provisioning domain. And again, I talked briefly of this last year, I think. Provisioning domain has the set of properties and configuration that you need to use, which is the interface, which is my prefix, which is my address, which is my next stop, and so on, and my DNS server. And when you are using one of those elements, you need to use all of them in the same bundle. Okay? I am using my mobile interface. Then I need to use the DNS server of this mobile interface, right, from this mobile provider, not the one coming and got from Wi-Fi, for instance. So we basically on this draft, and I say we because I'm a co-author on this, we are again extending the route advertisement by another option, where there you can put the name of the providing domain, which is actually a fully qualified domain name. It identifies the bundle. Okay, it says, okay, all those parameters that are received in the array, and there are flags to handle DHCP as well, needs to be considered as a bundle. So when I'm using one of the configuration items, I need to use all of them. One thing, and we can also use this fully qualified domain name basically to request over TLS a JSON file that describes more. Oh, this is, for instance, for video, or this is the one for video setup boxes, or this is for low latency or whatever. That's it. Talking about route advertisement, a very recent one from Ule, yeah, familiar name, right? We see all of them. Because he's a chairman of Sixman, and they are annoyed by getting many people coming to Sixman. Hey, can we get another option for route advertisement for doing this? Can we get another one for doing that? So his point was to say, hey, why not doing something such as universal route advertisement, which will be, of course, type, length, as usual in those things, and data. And the data is simply a JSON file, right? And then there will be, of course, in the IANA, which register all those same numbers in the IETF, there will be a registry for IETF, and then DNS or NAT6 for all those keys will be into a registry there. So to allow interpretation, of course. It's version 0.0, so pretty new. I'm sure it will go there. But you can really feel the working group chair, which is annoyed by getting so many requests for another array option here, yeah. So as we are in Troopers, so my dear friend and Enno will go through Prague, present this. That's a work we have done for many years now. In OPSEC, so operational security. And that's basically consideration. Before it was recommendation, but we have to change to consideration for IPv6 network. It's a very long one. It all started. So it's mainly focused on enterprise service providers, residential, a touch on the mobile data and 3GPP, but nothing on IoT because there are so many IoT use cases that's not easy to make any recommendation or consideration here. Topics is about addressing extension headers, neighbor discovery, basically what are the differences, and we point to other documents or give some consideration. So again, I said we are using consideration, but for instance, we talk about ULA, right? You remember this universal local address? Because we think we need to say a few words on this, assuming the reader is unaware about all the complexities of everything. But as soon as you mention ULA into an IETF document, you see some well-known friends, right? Italian guy working. Yeah, I mean, we know them, right? So, and then boom, boom, bazooka, 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 bazooka again. Remove this and blah, blah. So now, I think, you know, we are completely pissed off by all those back and forth. You need to say this and this. That we say ULA exists, and we refer to another draft. So we went from 5-page or 2-page or whatever on ULA to 2 lines. So now, if we are still stuck on this, yeah. So there are, before giving the floor to Fernando, other drafts as well, but I have no time to go through it. Again, I try to give you a hint of multiple areas about the variety. It's really up to you to dig further. And I would love as well to thank you not only for listening here, but please act on this IETF, right? The IETF is not reserved to some superpower or super duper engineers or whatever, or gods. It's about engineering. Okay, there are some politics to be true, but most of the time it's about plain engineering. So all of us in this room can basically participate in what we call mailing list. You go to the IETF.org website and you will find everything. You can register, it's free. When I'm talking there, even with my Cisco.com address, I'm representing Eric Vink, not Cisco. Okay, so that's not about vendors. Now, again, there are some vendors politics there, right? Don't take me wrong. But it's free. And you can review draft, you can auto draft. I mean, writing a draft that may become an RFC is just writing right now in the version 2 of the process, and we are moving anytime soon to version 3, needs to be XML. Okay, so you need to understand somehow the XML. But you got tools for doing something different. I don't know which tool you are using, Fernando.
The online tool, whatever it is.
Okay. Even I'm using XML and an XML editor. So basically, please participate at the IETF. Just review, and people like authors like Fernando or myself or yourself, we are quite happy when we got some review. So people telling, hey, what's there, what's there. Don't blame me again about ULA though, right? I've done way more. So Fernando, up to you.
Well, this is like Latin Americans' heaven, because I get to be late and blame somebody else. So usually it's my fault, so now I'm going to enjoy it. First of all, I'm quite glad to be here again. For me, it's always an opportunity to meet with colleagues, and besides, the excuse of, giving a presentation, for me, the most important part is, when you talk to people, even at the speakers dinner, I have had like very funny and interesting conversations while drinking beer there. So this presentation is going to be about some specific RFCs and IDs that are active at the IETF. So it's what's new at the IETF. If you look at the content, you might think like that. So I'm going to cover a couple of topics. There were many IDs and many RFCs going, being published or being discussed at the IETF. And when I was deciding what to, which ones to discuss in this presentation, I tried to, group them somehow in some way, so that it didn't look like, stuff that didn't have anything to do with each other. So I decided to actually focus on all of those RFCs and IDs that somehow had to do with addressing. First one of all, you might remember that we have the IPv6 addressing architecture, which is RFC 4291. And there was, or there still is, the project of moving this RFC to standard. Actually, one of the goals of Sixman is to move all of the core RFCs to internet standard, full standard. That happened already with 2460, which became which was replaced by 8200. This was the plan for the addressing architecture too, but progress on this document has been stalled for quite a while. Discussion has been mostly about the requirement, if you want, to force a /64 for subnets, okay? So there are folks that think that, like /64, that requirement is part of the architecture, whereas there are other folks that believe that that's not part of the architecture, okay? So essentially, progress has been stalled over there. And it's unclear, how things are going to progress when it comes to this document, because it's like, like lots of people on one side and lots of people on the other. My personal view is I don't think that any specific value belongs to an architecture document. Like, it's not architecture. Then you can put that requirement elsewhere, like, in SLAAC and so on, but that shouldn't be part of the architecture. That's my take. Of course, if you wonder what is all this discussion about, well, the folks that try to, or that think that this /64 should be enforced in the architecture, they think, and probably to some extent they are right, that if this /64 is not required in the architecture, then ISPs are going to start reducing the amount of addresses that they are going to lease to clients, and eventually they're going to run down to the bottom and eventually lease in a single address, and we go back to IPv4. That's their take. Other stuff related to addresses, this is kind of like a status update, if you want. You know that we have stable addresses and we have temporary addresses. The stable addresses used to, at least the standard ones, Windows used to do something different. They used to embed the MAC address in the interface ID. We changed that years ago with 7217 via 8064. So essentially 7217 specifies the algorithm,
and then 8664 tells you that you have to do 7417. That's kind of like procedural stuff, if you want. But the nice thing is that after a while, if you look at many popular operating systems, nowadays they ship with 7217 on by default. So at least all these ones. I think that Windows still does something else. But it's anyway, it's good news. I mean, from my perspective, when something that when you have worked on something that is a piece of paper standard and it actually makes to an implementation, that's a good thing. If it just remains on paper, there's no point to that. So eventually, BSDs, most distributions of Linux. Linux has implemented support for this in the kernel. Network Manager also implements support for 7217, and there is a daemon called DHCP CD, which is, for example, Raspbian uses that for automatic configuration. They also default to 7217. So if you do a fresh install of any of these systems and you see that the addresses have changed, well, this is the reason. Then temporary addresses. Temporary addresses, are widely supported. They are enabled by default on some platforms, not in all of them. Like Windows is one of the examples where temporary addresses are enabled. But there are a number of issues in the spec itself. So it's not implementation flaws, but actually in the spec itself there are things that should be improved. And this is what comes in the in the next slide, in the next slides. So that should. There we go. So I mentioned that we had some issues in 4941, the RFC for temporary addresses. Obviously, if those are issues related to the specification and not with an implementation of it, then they had to be fixed in the standard itself. So that's why we published this draft, which has already become a working group item of the 6-man working group. That tries to fix those remaining issues in 4941. Without getting into too much detail, among the things that we want to change in the revision is, first of all, allow the use of only temporary addresses. If you look at 4941, it assumes that temporary addresses are always employed along with the stable addresses, okay? Obviously, there's a reason for that, because for a general purpose system, you don't know if it's going to act as a client or as a server. So you want to have both types of addresses. But for example, for a mobile phone, you might want to just use temporary addresses. We want to allow the use of it. It's not that we want to push for that. Other things or other aspects that we should improve in 4941. For example, 4941 says that if you have different prefixes on the same network, you will use the same random identifier in all of the prefixes, okay? Well, of course, that's not nice from a privacy point of view, because if the ID is the same on all of the prefixes, then you can correlate the addresses by looking at the interface ID, okay? You have connections coming from different prefixes, all of them use the same 64 bits. So from a privacy point of view, of course, that doesn't make sense. So we want to recommend against that. So if you are configuring temporary addresses and you have different prefixes, well, each address should use a different interface ID so that you cannot correlate the activity of each other. There are also cases where an implementation reuses an interface ID when it moves from one network to another. So the interface ID only changes as a function of time, okay? But of course, if you are moving from one network to another, the interface ID should change. That should be obvious. Other stuff, there's also a limit on the number of non-deprecated addresses that you can have at any point in time. And what we would like is that at any point in time you can have multiple addresses that are active on your system. Obviously, from a privacy point of view, that's a good thing. And the final one is that 4941 recommends to disable temporary addresses by default, and we want to enable them by default. So the default setting should be that temporary addresses are enabled. If you don't want them, turn them off. There's still work going on this ID. So if you have the time and you're willing to, reviews are appreciated. We try to keep as much of the content, the original content as possible, and only change the parts that were really necessary. But still reviews are necessary. Other stuff, I will try to go faster on this one so that we catch up.
Yeah, I mean, we could maybe move some part of that into your second slot in the afternoon.
Yeah. So tell me at which time we have to.
Yeah, maybe 10 minutes. So people still can have lunch.
Okay.
I apologize as a chair for that.
No problem at all.
Going over time myself, then not cutting Eric, and then now you're the guy who has.
That's karma. That's karma. But yeah, I still have time in the other slots, so there's no problem for that. So the other one is this one is actually quite interesting for two different reasons, which I will discuss briefly. So if you look at IPv6, or the way I look at IPv6 is that it's all about the extra addresses, right? So you are deploying V6 because you run out of V4 addresses, and that's the whole point of V6. You have there's a lot of potential when it comes to addressing because you can use as many addresses as you want. I mean, there are plenty of them. And there are also different properties for the addresses. Like, for example, you have addresses of different scopes, which to some extent you have in before. And there are also addresses of different properties, such as stability, for example, okay? So in theory, there are a lot of things that you could do with that. Now, problem is that while you have all the stuff in the standards, there's not much guidance about when to use which kind of address and for what, okay? So you have all those addresses configured on a system, but still the applications are clueless about that, and the operating system doesn't do much about that, except policies like okay, prefer temporary addresses, but not much more than that. Okay, this I mentioned. So we can talk about three different properties. There might be others, but the ones that at least I found interesting from a, let's say, security privacy perspective are these three: scope, stability, and usage type, which of course have implications. So let's start with scope, and this is related to what Eric presented in his during his talk. If you have, for example, a non-global address scope, that provides some kind of like prophylactic security, meaning that in theory it's you cannot reach those addresses because you are out of scope. It's like if you are connected on a local network here and you try to get to my linked local addresses at home, you won't be able to, okay? Of course, then there are the small details and things that you can do, but that's a security-related property with the scope. ULAs are one specific case of this. I'm not going to get into the discussion whether you should use them or not. I mean, it can be argued one way or another, but these addresses are still there. And the most important point from my perspective is that the standards do specify these addresses, but there's no guidance on what to do with them. So that's essentially the point that I'm trying to get to. Like, you have lots of addresses on your system, addresses of different properties, but nobody tells you, what to use, which address, and for what, okay? Then there's the issue of stability. I mean, it's obvious that, the longer you use an address, the more it is exposed for, different reasons. For example, if you use constant interface identifiers, like, the traditional SLAAC addresses, the nodes can be tracked across networks because obviously you have 64 bits that are globally unique. So that means that by looking at the interface ID, you can essentially identify what's the node that you are communicating with. So those are, if you want, the traditional SLAAC addresses. Then we have the stable per network addresses, or the 7217. Okay, these are addresses that are stable as long, or interface IDs that are stable as long as you keep connected to the same network, but they will change when you move from one network to another. So 7217, what it does is you connect to a network, you always compute, or you always get the same interface ID. You move to a different network, the interface ID changes. You go back to the original network, you get the same interface ID. Okay, that's that's a design goal. Okay, but on one hand, they are nice from an operations point of view because the addresses are not changing all the time. On the other hand, of course, since they are stable within the your network, you can correlate activity over time. Then we have temporary addresses, okay, which are supposed to limit the ability of an external party of correlating network activity. So you have addresses that, for the most part, you will use for client-like activities, like browsing the internet, browsing the the web, and they are changing over time. Of course, it's you might argue to what extent this is effective or not, because, for example, it's typical that these addresses change, for example, once a day. Now you might say, well, is it enough to change the addresses once a day? Well, maybe not, okay? Because obviously, during that whole day that you are using these temporary addresses, network activity can be correlated. And then there are these, let's say, throwaway addresses rather than connections. This is an idea about, rather than configuring an address and using it for everything that you are doing, just configure an address, use it for whatever you wanted to use it, and then remove the address. You'll see that when I do the presentation in the afternoon about the toolkit, which is like a short presentation, I use this concept to actually do queries to search engines, which essentially rate limit you. So if you're able to essentially send each query from a different address, even more if it's from different prefixes, and you can get different prefixes, of course, the search engines are going to believe that you are a totally different client, and it's okay. So at some point in time, before implementing this, I had to have like different machines, because I couldn't do as many queries as I wanted. Whereas using this concept, I can use a single machine, and I use a /48 just for that machine, and I just spoof addresses from that whole space, okay? Then there's also, I mean, besides the specific usage, there's also like, I mean, right now there's not much of, let's say, of advice about when to do what. For example, you might argue that, for the general case, or by default, you might want to do these two, which is stable addresses plus temporary addresses. But of course, that depends on the type of, platform, or, what you expect to do with, that device. And so far, there are no recommendations about that. Like, if you have a, let's say, a mobile device, which addresses should you use? Like stable, temporary, both? Well, it's left to the implementer if you want. And there's another one which is interesting, which is, the idea of having stable and temporary addresses is that you use the stable addresses for incoming communications, because usually you will want to, post the addresses on the DNS, for example, and you don't want to be updating the DNS all the time. And you use the temporary addresses for the outgoing connections, okay? So that's kind of like the idea. Now, there was like a real world, before getting to that, now there is a problem or a limitation that has to do with the APIs, essentially. If you have done any, sockets programming, you know that normally when you want to, let's say, bind an address, this is the system call that you use, or the API that you use. And essentially, bind allows you to do two different things. Either bind a specific address or bind any address. but you cannot bind, for example, like a subset of the addresses. What does it mean? That if you have a system that has, for example, is using different prefixes, and it has temporary addresses and stable addresses, well, either you listen for incoming connections on all of the addresses or on one specific address. But you cannot do something like, for example, just listen on the stable addresses. Now, you might say, well, why should I care about that? And this is a real-world example. Short version of the story is like this. There was a guy that had a Raspberry Pi, fresh install. He connects the Raspberry Pi, to the internet, but he didn't do anything. And a couple of minutes after that, he gets a port scan. So he said, well, from where? I mean, how did they know that my system was alive? Well, turns out that the guys at Shodan, they had volunteered to run an NTP server as part of the pool of public NTP servers, and I guess as a kind of retribution to the service for the community, they decided to scrap the addresses and use those addresses as input to their search engine. Okay, essentially that meant that if you were using, let's say, any Linux distribution that was using that pool of NTP servers, and you happen to be connecting to the NTP server that these guys were running, well, they would learn your address and then they would port scan you to actually, incorporate your system into their search engine. Not nice, of course. Now, I mean, besides the fact that, well, this is not nice, then there is this other question. Like, let's say that I had a Raspbian system and I connected to an NTP server. So what I did was like a client-like activity, okay? So I was consuming some service from the internet. So these guys, the guys running the NTP server, they learned but my temporary address. Now, obviously, if that's the only address that they learned, that's the address that they are going to scan. Now, the question is, why should I be accepting incoming connections on the temporary address? Temporary addresses are only meant for outgoing connections. Well, that's a limitation of the API. So since the API doesn't allow applications to bind a subset of the addresses, or, for example, specify the properties. Like if you have an application, you should say, well, it's a server, right? So I want to bind my application to the stable addresses, never accept incoming connections on the, on the temporary addresses. You just can't. The only way in which you could do it, and you should do it probably, is to set up a firewall. And you allow incoming connections on the stable addresses. You whitelist those addresses if you want, but you block all of the others. If you were doing that kind of stuff, that meant that anybody that learns your temporary addresses, because you were consuming stuff from the internet, they are not going to be able to use those addresses because you don't accept incoming connections on those. So in this specific example, these guys running the NTP server would have learned your address, but then when they scan you, you just drop those packets because you don't accept incoming connections on the temporary addresses. I mean, that's something that could be done, but because of the limitations that we have in the APIs, the only way in which you can possibly do that nowadays is just configure a firewall.
Would that be a good point to...
Let me, one more slide. Yeah,
I mean,
one more slide.
Bad conscience anyway.
The thing is essentially that there's a lot of work to be done in this area. Like, from my perspective, the whole point of IPv6 is the addressing part. Like, you can have as many addresses as you want. We have like lots of different properties, but there's not any work on, how you can actually make use of them. Now, I was, let's say, puzzled in a way that when I submitted this draft, I presented, this document at the 6-man meeting. Also talked to people in other working groups, and there didn't seem to be much interest. So, I mean, it's not the idea that is important, but the fact that you have all these things specified, and there's no guidance, for people on how to configure them, on how to use them, I think that there's something missing there. So this is our breaking point. So that was the end of the presentation about the toolkit. Now I'm going to go back to the presentation that I did today in the morning. For those that were not here in the morning, it was a presentation about stuff that was going on at the IETF. And the last topic that I had mentioned was about the lack of advice when it comes to the use of IPv6 addresses, okay? There's a document that I mentioned already in the morning. This one essentially discusses, you know, all of the stuff related to addresses, like, you know, proper security and privacy implications of different properties, like, you know, scope, time frame, and so on. Now, there is the last bit. I don't know if, does anybody of you follow the 6-month mailing list or B6 Ops? One, okay. Well, if you do follow one of those mailing lists, there was, during the last month or so, quite a, let's say, long discussion about an internet draft that we co-authored with a friend of mine about the reaction of SLAAC to renumbering events. If you didn't, you know, if you didn't read about the discussion, this might be useful because I might be pointing out a problem that you might be having or you might have in the future, but you were not aware about. So let's consider this typical deployment scenario for IPv6, okay? So the scenario is quite simple. You have your ISP, you have your home router here, and you have your local network, okay? Normally, you do SLAAC on the local network, and you do DHCP prefix delegation towards the ISP, okay? So your router requests a prefix from your ISP, and then advertises some prefix, some subprefix of this prefix here on the local network. That's normal, 100% normal. Now, the question is, what happens in scenarios, for example, such as when the CPE router crashes and reboots, okay? So again, in the normal deployment scenario, you have this situation. The CPE router does prefix delegation with the ISP. It receives a prefix, and then it advertises on the local network some subprefix, okay? You might get, let's say, a /48 from your ISP, and then you advertise some /64 belonging to the /48. Now, this we did. A comment before we get to the actual problem. You probably know that both in SLAAC and in DHCP, there are lifetimes or lease times involved. Even that's the case also with the DHCP version 4. So you request an address, and the DHCP server tells you, well, it's okay, you get this address, and you can use it for this time frame, okay? The same applies to DHCP version 6, prefix delegation, and also the same applies to SLAAC. Normally, the lifetimes that we are talking about are in the order of months, or in the order of 1 month or so, okay? So it's certainly over than a week. Now, what happens, for example, in the problem scenario that I mentioned? The CPE router just, you know, crashes and reboots. Normally, these devices don't record the prefix that they had been leased before on any kind of stable storage. So when they actually reboot, they don't remember what is the prefix that they had been leased before, so they request a new prefix to the ISP, okay? And they obviously advertise on the local network the new prefix that they got. Now the question is, what happens with the previous prefix? So if we go back here, I have my router, I request a prefix, I advertise on the network. This one crashes, now it receives a different prefix, and advertises a new prefix here. That's okay. But what happens with the old prefix? Because no one of these systems here are aware that the old prefix is not valid anymore. Okay? So at some point, this router said, okay, you can configure an address for this prefix. You can use it for a month if you want. Now, when this router reboots, it never tells the systems on the local network that the old prefix is actually stale, that it's not valid anymore. Now, the end result of that is that all of the systems that you have on the local network, they keep the old addresses and they also keep the old routes. And they are not going to remove neither the addresses nor the routes until the lifetime of those prefixes expire. Now, if we go back to the, what I mentioned about the lifetimes, we are talking about lifetimes in the order of 1 month, meaning that the network configuration is going to be skewed for a month. What are the implications of this? Well, you might be having this problem right now, you just might be not aware about it. Why? For example, if you have a dual stack network at home, if the IPv6 configuration gets screwed, well, because of happy eyeballs that you might hear about it here, essentially happy eyeballs, the simplified version of it, is that when you are trying to browse a site, you try IPv6 and IPv4 in parallel, and whatever works first is what you use, okay? Now, if the IPv6 configuration is incorrect, well, it's going to fail, but as long as before is still working, well, there's something that works, so you probably don't even realize that something is failing in there. I mean, it would be a different story if you go v6 only, because there's no fallback there, okay? Now, the reason I mention this is just one of the many problems that are many times masqueraded by the fact that you have dual stack. Dual stack, as long as something is working, you don't realize about the failure. Now, when you start depending on a single protocol, if that protocol fails, well, the problem becomes evident. You might wonder, well, how could you possibly, let's say, avoid this problem? Well, RIPE had published a document, I think it was RIPE 590, if I remember correctly. It was a recommendation for the prefix sizes that should be, let's say, leased by ISPs to customers. I think it was 590 or something like that. So what they say, what that document says, is that the ISP should lease stable prefixes. What does that mean? That it should always give you the same prefix. So if the CPE crashes and reboots, well, the old addresses are not going to be stale because you are going to get again the same prefix. So, I mean, the problem is still there, it's just not evident. Now, there are, some, pros and cons for that. On one hand, for law enforcement, it might be nice to give the users, stable prefixes because, it's easier to identify the user. Maybe not for user privacy, okay? I guess it's the same thing with IPv4, that if you want, a stable address, you have to pay extra. So whatever the reason, I mean, at the end of the day, there are deployment scenarios in which you do get dynamic prefixes, okay? In some cases, it could be because the, for example, what was reported to me by some ISP was that it was difficult for them to do that with their provisioning system that they had. There are other cases in which they might not be aware about this, but the reality is that you are going to have deployments in which you do get, dynamic prefixes. And in many, many cases, the CPE routers that you have, they don't record the prefix that they had been leased before. Of course, if they did that, when they are rebooted, they could try to, let's say, disable that prefix on the local network, like advertise that prefix, but with a lifetime of 0. Okay, so that any host that had configured an address for that prefix will remove that address. So this is a problem that is actually around, and the reason for which I ended up co-authoring this document was because there was an ISP that asked the question, well, how do we solve this?
Very quickly, just
Yeah.
so people have an idea what this thing is about. But this is kind of IPv6 history. This is what Deutsche Telekom had. What had planned at the time, and this was the internal the strategy. Well, have a privacy button and have privacy extensions, and you see all that. It's a German approach, very detailed and a bit complicated. It tries to find the exact right balance between different objectives, and there was a lot of effort put into this, but actually never took off. This has never seen the light of life, kind of. If anybody's interested, I'm pretty sure I'm allowed to share this, given this is like 7 or 8 years ago. But there was this whole thing around the handling of prefixes by
there's
ISPs. And you say they every time you reboot, you get one?
100%.
Is there, I believe, is there any way you can trigger that? Except for rebooting, of course.
Yes, you have this button actually.
They have?
On the speed port, well, it's simply a reconnect.
Okay.
So then you're getting a new IPv4 address on the Untrust interface as well as a new IPv6 prefix.
Yeah.
But you have to explicitly use it. Yes.
And I mean,
every time I'm using the
Sorry,
Fritz box
jumping
on the speed port, however, every time I'm rebooting the Fritz box, I'm getting a new IPv6 prefix. My whole internal network in the mirrors.
Well, an interesting part is that normally when you call the ISP reporting a problem, usually the number one approach for them to solve the problem is like, have you tried rebooting the router? So actually this would break the B6 deployment in these scenarios.
On the phone via voice call.
Yeah.
which is, funnily enough, if you look at this, at the time, there's many funny things in this. This is 2012. And okay, IPv4 addresses are scarce. We need IPv6, so some things haven't changed for a long time. But there's exactly this. If you look here, why the zwangseitige Netzwerktrennung, which is again very German, zwangseitige Netztrennung, netzseitige Zwangstrennung, very German thing. This could lead to loss of connectivity, which would then be needed for phone calls. So same discussion. Again, if anybody's interested, drop me an email. You can get this, even though it was like internal at the time.
Let's put it here.
So, but huge debate around this.
Let's see. Tap. There you go.
I would say you have another 5, at max 10 minutes.
Okay. Okay, so one of the possible ways to avoid this would be to use stable prefixes, but for different reasons, it might not be possible, or the ISP might not want to do it. Okay, so that means that there is a problem to be solved. The other thing, because quite frequently when you bring some problem like this, particularly to the 6-man working group, the attitude is, well, there's no problem, so it shouldn't be solved in the protocol. So they blame the ISP because of the way in which they deploy the protocol, but there's nothing wrong with the protocols, okay? Now my take is that no matter how you deploy V6, the network should be resilient anyway, okay? If you use dynamic prefixes, for whatever reason you do them, well, the network shouldn't break because of that. Another way in which this problem could be avoided somehow is if the CPE were to record the prefix that was leased. So let's say whenever you get leased a new prefix, you record that prefix on stable storage. Then whenever the CPE router gets reboot, if it doesn't get the same prefix, it could advertise the old prefix with a lifetime of 0, trying to essentially disable the prefix. In practice, it doesn't work because the standard says that if the lifetime, if a router advertises a lifetime of, let's say, less than, I don't remember how long it was, like less than an hour, the lifetime should be ignored. So it's not possible to actually completely disable the prefix. Then there was another proposal, or there was a proposal on how to solve this, which essentially boils down to this. So there was a proposal to solve this problem by updating the source address selection algorithm. I mean, if you have never heard about source address selection or about .RFC, the idea is that, you know, when you have an IPv6 host and you have so many different addresses, then when you want to contact some other system, you have to, you know, pick one of your addresses. And the decision is not always straightforward. You might have different prefixes, you might have addresses of different scopes, and so on. Now, there are so there are a number of possible ways in which you could do this. For example, some people suggested that you should look at the value in the prefix lifetime and always use the one that has the largest value, okay? So if, let's say, the stale prefix had a lifetime of, let's say, 2 months, and now there is another prefix that is advertised with a lifetime of, let's say, 3 months, you should use the longer one. Well, that doesn't really make sense, okay? Then there is another option that was proposed, which was like this. These people suggested that you should always use the prefix that was last advertised. So in theory, I mean, this modification, in theory, would solve the problem. Why? Because obviously, if we had the old prefix, now the router crashed, reboots, it gets a new prefix and advertises the new prefix. Well, the new prefix is the last one that has been advertised, okay? So you use the new one and not the old one. But what happens, for example, if you have a deployment in which you have 2 routers that are advertising 2 different prefixes and both of them are working? So when this one advertises the prefix, now this prefix becomes preferred. Now when this one sends an RA, now this prefix becomes preferred. So now the source addresses are flopping from one to another. That's normally not nice from an operational point of view, okay? That is like a guarantee that over time you have no clue about what's the address that is going to be used because it's changing all the time. Unfortunately, I wouldn't be surprised if the IETF decides to solve the problem this way. Seriously. My personal view is that they always prefer to update the most irrelevant RFCs. So it's like, you know, 2460 is like the Bible, you just don't touch it. So this is like, well, source address selection, it's like not part of the core specifications, so you can play with this one. We can give you this one to play with. But obviously it shouldn't be solved here. And there's another one. Like, even if you prefer a different prefix, that hasn't removed the address from the system. So you still have the old addresses, you're just not using them. Now, for example, if you keep the old addresses, you are not going to be able to communicate with the new owner of the prefix. So if the same prefix that you had before now has been leased to a different system, you will not be able to communicate with it. So that's not the way forward from my perspective. What I propose for this, like the easy way to see it, or my solution to the problem is as follows. Let's say that he was advertising some prefix to me, so I am the host, right? Obviously, my take is that the problem should be solved at the host, not on the routers. So let's say that he was advertising some prefix to me, prefix, let's say number 1. He crashes and reboots, and now he's advertising prefix number 2. Now, since I didn't crash myself, okay, so now I see that he's the same router as before. He's advertising prefixes, but he's not advertising the prefix that he used to advertise, okay? So you're sending arrays to me with different prefixes, and you are not advertising the old prefix anymore. So my solution to the problem is that as I continue receiving arrays from you, and I don't see the prefix that you used to advertise, for example, after the second array or third array that I get from you with other prefixes other than the previous one, you should remove the old addresses, okay? So it's like you have the server or the router that was sending the, the prefixes that you should use for configuration. All out of a sudden, you get different information than the one that you were receiving before. So, and you keep receiving, consistently new information, and you don't get to receive the information that you used to receive. Well, from my perspective, that's an indication that the information became stale, okay? And you should get rid of the addresses, get rid of the routes, and you start from a clean slate. Well, some people at the IETF think that that's not the way to move forward. There's my conspiracy theory about this one, because I do have one. The Sixman has the goal of moving the core specifications to full standard. For me, that's crap. But from their perspective, if they move the specifications to full standard, that's like an indication to the world that the protocols are mature, okay? Now, there's a tricky part there. There's a requirement that in order for you to move a specification to full standards, there shouldn't be any major changes. Now, if you do apply a change to this, which is SLAAC, that means that you cannot move SLAAC to full standard. Now, if you ask me, I prefer to do the right thing from a technical point of view than doing politics at a group that is supposed to do technical work. But sometimes the politics and the technical part are not... Well, when they were, when the core B6 specification 2460 was just about to be moved to be republished as full standard, I got comments from many people from like very high level at the IETF that everyone would say, well, it shouldn't really be moved to full standard because, I mean, there are things that are broken in the protocol, like extension headers, for example. But it's like, well, from a political point of view, it's we have to, publish the core standard, the core RFC as a full standard as an indication that the protocol is mature. Okay. Now, I think this is the last slide. When you think about this, this problem, it begs a number of questions, such as this, for example. Normally, when you look at arrays, the prefix lifetime is normally valid for 1 month. So that means that the prefixes that are advertised on the local network are valid for 1 month. On the other hand, the router lifetime is valid for 30 minutes. That doesn't make much sense. Now, this is where things get like, very crazy, if you want. I ended up, when I was trying to push this forward, I said, well, I need some old guy on the, on my team. So I ended up finding one of the early authors of Neighbor Discovery, which we had fought other battles on other working groups. And he was the original author of the SLAAC specification. And he mentioned that, for example, the reason for which you get 30 minutes for the router lifetime is because at the time it was specified, the IETF was playing with the idea of using these protocols to communicate with systems on the moon. But the thing is, now you get the value 30 minutes and somebody comes up with an explanation of, you know, where that comes from. Now the guy that actually knows why that value is there, you know, tells you the reason. I say, well, that's crazy, you know? But the problem right now is that, you know, that's in the specification and people will, you know, defend the values that they have in the timer as if they made sense, when they actually, the values that you have there are there for completely different reasons. So for example, when it comes to the lifetimes, I think that the prefix lifetimes should never be larger than the router lifetime, meaning that they should never be larger than 30 minutes. If we were to use those values and we had this problem scenario, at least the network would be broken for 30 minutes, but not for a whole month. Okay, I mean, still broken, but the level of brokenness, it to be smaller. Then there is another thing related to, okay. This is related with ULAs. This is like food for thought, if you want. So I was talking with these people, like, you know, why the hell do you need a, you know, a prefix lifetime of 30 minutes? Well, thing is, in IPv6, you're not supposed to have NATs, okay? Now, what happens if the lifetime was set to something like 30 minutes and you lose connectivity with your ISP? Addresses expire and you don't have any addresses anymore, okay? If you ask me, that's what ULAs are used for. So if you want to have addresses, even if you lose connectivity with your ISP, that's what ULAs, that's a use case for ULAs. But there was other people that proposed that the way to solve this problem is to use NAT. So that's, well, any questions? The only thing that I would like, let's say,
One more thing.
yeah, to keep in mind is just keep this problem scenario in mind, okay? Well, what I keep hearing is that I talk to ISPs, and whenever I bring them some of these things, like, you know, how did you solve this? They are not even aware of what the problem is. So keep this in mind. I'll be around. If you have questions, email me. There's B6 Hackers mailing list where you can subscribe. It's open and so on. And that's it for today, I guess.
Thank you.
Thank you.